Using composition of functions, prove that g of x and the inverse of g are inverses of one another. So I'm going to start by doing g of the inverse of x, and then I'll do the opposite. In both cases, I want to get an answer of x. So I'm going to take, what is the equation for g? It is y equals 2x minus 7. That's what g is. And wherever I see an x, I'm going to take out that x and leave a really large parenthesis. Inside the parentheses will be the inverse. In this case, it's x plus 7 over 2. The inverse is on the inside, and it's plugged into the outside, which is g of x. Okay, let's simplify one step at a time. 2 on top simplifies with 2 on the bottom. 2 divided by 2 is a 1. Positive 7 and negative 7 simplify to 0. Make sure to do one step at a time. X, y equals x. Okay? So, in position to prove that these two are inverses. If y does not equal x, I can stop, and I can assume these two are not inverses of one another. Okay, now I'm going to write down the inverse. So the inverse is y equals x plus 7 over 2. And I left the x out so I could replace it with what g of x is. G of x is 2x minus 7. X plus 7 over 2. Replace the x with g of x. Okay. So when I simplify, the order here doesn't matter. I'm going to start with simplifying the numerator. So negative 7 simplifies with positive 7 to equal 0. And 2 divided by 2 simplifies to equal 1. So I just proved using composition of functions that g of x and the inverse of g are inverses of one another.